All right, folks, we are back with more stoichiometry. Today we're going to be going over gas stoichiometry and mass stoichiometry. Now, we did stoichiometry last week. It's something that would take multiple weeks in a class setting as well, so don't be surprised. We're going to spend a little bit of time on it. We saw last week that mole stoichiometry involves moles. And so you are given a chemical reaction. Sometimes you have to balance it. Sometimes you have to predict products. That's stuff from Science 10 that we've gotten pretty good at. But after that, you use the numbers in front, the coefficients, to predict amounts of product or to talk about how many moles of reagent we need. So today we're going to be talking about mass stoichiometry, which is exactly the same idea, but instead of displaying our answer in moles, we're going to display our answers in grams. And in gas stoichiometry, we'll express our answers in a volume usually, like how much volume of gas can we make? And that's a little bit trickier because gases are contingent upon the pressure and the temperature. Remember, if you heat a gas up, it expands. If you cool a gas down, it contracts. So that adds a little bit of challenge to the questions, but we're not going to do too many of those. So as far as mass stoichiometry, yeah, it deals with grams instead of moles, meaning that we're going to be leaning on the mole ratio, but we're also going to need to make use of molar masses. And remember, molar masses are conversions. They're how many grams does 1 mole of a particular chemical weigh. So we still use the balanced chemical equation. We still use the mole ratio. So let's take a look at this question here. We've got 4 moles of iron combining with 3 moles of oxygen, giving us 2 moles of Fe2O3. That's iron 3 oxide. I've already got the molar masses of all the chemicals involved in this here. Notice there are no coefficients. You never use coefficients when you're calculating the molar mass. It's just how much does 1 mole of this chemical weigh? So it's like 1 mole of Fe weighs 85 grams. 1 mole of oxygen, which is O2 gas, weighs 32 grams per mole, or 32 grams. 1 mole of iron 3 oxide weighs 159.69 grams. So all we need to do now is take a look at our question and try it to see if we can solve it. So how many grams of oxygen do we need to make 200 grams of iron 3 oxide? So remember, chemical reactions they deal with moles. So we got to get everything in this question has to be in moles first. So I have iron 3 oxide, and what I'm going to do is I'm going to write down 200 grams of Fe2O3. We're going to turn this 200 grams into moles. How do we do that? Mole ratio. Molar mass. So our molar mass is here, 159.69 grams per mole. So I know that my answer should be in moles of Fe2O3. So how do I turn grams into moles? Well, I need moles on top, so the moles number is going to go up top here. And my grams number, 159.69, will go on the bottom. Why do we do it this way? Because grams on top cancels grams on the bottom. The only unit that survives is moles. Keep in mind, the number that hooks up with grams is always going to be the value that's not 1. It's going to be the interesting number. The thing that goes in front of moles when you're doing a moles to grams or grams to moles conversion is always going to be 1. So grams to moles, moles is always on top. Grams is always on the bottom with the cool number. And I did the math on this, and it's approximately 1.25 moles. Now I've got the real number here. It's like 1.252 blah, 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 whatever. So I'm not going to worry about that too much. I'm not going to round this in my answer until I get all the way to the answer. But now we have to throw this into the mole ratio. So the mole ratio is required over given. So I'm going to say 1.25 moles of Fe2O3 That's what I've got. I'm going to set up my little ratio. And I know that my answer is going to be in mole of O2. So I'm turning my Fe2O3s into O2s. How do I do that? I put O2s up top. So we have 3 O2s up top. And we have 2 Fe2O3s on the bottom. Remember that when we're multiplying by a fraction, we multiply by the top number and then we divide by the bottom number. So we'll go 1.25, whatever the actual number is, times 3. Then we'll divide it by 2. We got approximately 1.88. Again, it's not that exact number. It's like 1.8786, but that doesn't matter until the very end. And we're going to be giving this answer in 4 significant digits. So now we have to turn our mole of O2 into grams of O2. So we're going to use 1.88 mole of O2. And now we're using the molar mass, and we're going to get an answer in grams of O2, which is what the question wants from us. So we want to get rid of moles, so 1 mole goes on the bottom. That's the mole up here. That's the per mole. And then 32 grams up top. So 32.00 grams up top. I do my little math. I get 60.12 grams of oxygen. So this is a way we went from grams of one chemical to moles of that chemical. We went from moles of that chemical to the one we wanted. Then we went from moles of the chemical we wanted back to grams of the chemical we wanted. And now our answer is done. Let's try one more. I'm going to give you a quicker way of doing this that actually kind of solves everything out really nicely in a kind of a quicker way instead of doing 3 different lines of work. So how many grams of iron oxide can we make? Okay, so that means my iron oxide is my required. And we're using 145 grams of iron metal. That's my given. So first of all, we go from grams of iron into moles of iron. So 145.0 grams of Fe. I'm going to open up a bracket. Instead, I'm going to do this move. I'm going to turn it into moles, but I'm not going to write out the answer. I'm just going to continue on, and I'm going to do my second bracket, then my third bracket. I'm going to show you that everything else is going to cancel out. It's going to be beautiful, and in the end, we're going to have an answer in grams of iron oxide. So first thing, grams to moles of iron. Iron is 55.85 grams per mole. So 55.85 G goes here, 1 mole goes here. Now, if I were to do this math, I would get moles of Fe, but I'm not going to leave it there. Now, I'm going to do the mole ratio. In other words, how many moles of one chemical do we need in order to make how many moles of the other chemical? So I care about iron oxide. That's going to be in my answer. So how much iron oxide in the reaction? 2. So I'll say 2 Fe2O3. How many grams of iron? 4 Fe. There's my mole ratio. And now the next move, I need to turn my moles of Fe2O3 into grams. So now I'm going to use the molar mass. So it's going to be 159.69 grams per mole. Now I'm just going to quickly show you what's going on in here because it looks crazy and a lot of students don't like doing it this way, and I don't mind if you do it in separate lines, but this can be a lot more compact and it can save you a lot of work. It also saves you from like partly, approximating numbers, which is kind of a pain in the butt. So here's what we're going to do. Okay, grams on top, grams on bottom, it's gone. Fe, that's gone. Moles up top, moles in the down low, those cancel. What are the only units that survive? Grams of Fe2O3. So if we multiply this by all of the top numbers and then divide by all of the bottom numbers, we are going to get grams of Fe2O3. And we're going to look great. It's going to be perfect. So 145.0 times 1 on top times 2 on top times 159.69 on top. Then I'm going to divide by 55.85 and hit enter. Then I'm going to divide by 4 and hit enter. And then I'm going to divide by 1, which is not doing anything to the number, and hit enter. And we get 207.3 grams of iron oxide. So this is a faster way of doing this. I'm going to do one more example. I don't know which one I want to do. Let's do this one. So this one's a little bit trickier because I have not given you the reaction. I just said, okay, magnesium metals dropped into a solution of aluminum hydroxide. This means that in a question like this, you're going to need to predict what it's going to make. Now, I guess I kind of spoiled it because I have all the chemicals that are involved in this reaction over here. That said, here we go. So magnesium metal, that's Mg solid, is dropped into aluminum hydroxide solution. Okay, aluminum hydroxide is going to be Al, and since Al has a 3+ charge and hydroxide has a -1, we need 3 of them. So AlOH in brackets 3, and that's aqueous because it's a solution. Reaction arrow, we're going to be making, well, this looks like a single replacement reaction. We have an element and an ionic compound. That is going to signal to me that this element is going to displace or replace the aluminum ion. So we're going to have Al solid, and then we're going to have the magnesium hooking up with the OHs. This is something that students make mistakes on all the time. You're not just going to take this and hook it up with OH3, because when you look in your book, Mg forms a +2 ion. So you don't need 3 OHs, you only need 2 of them. So you're going to be forming MgOH2. So now that we've made all of our chemicals, now we have to balance them. Remember, this whole thing hinges upon your ability to do a balanced chemical reaction. So I've got 2 OHs over here, I got 3 OHs over here. 2 and 3 have a common multiple of 6, which means I'm going to toss a 2 in front here and a 3 in front here, which means I'll put a 2 in front here to balance my Als, and I'll put a 3 out front here to balance my Mgs. So I've got my balanced chemical reaction now. So how many grams of magnesium metal, so we're looking for this, do we need in order to make 50 grams of magnesium hydroxide? So I've got all of my molar masses here. So I want to know how many moles of magnesium hydroxide we're looking for. I'll do this one in the separate lines thing. So instead of doing it all in one line, which I really do like. We'll do it the other way, the easier way, I guess, or the more broken down way. So 50 grams of MgOH2. We are converting that into grams, which means we're using the molar mass, which is 58.32 grams per mole. So since we want moles in our answer, we're going to use moles up top and 58.32 on the bottom. So this is going to be, moles of MgOH2. So we do the math, 50 divided by 58.32, we get 0.857. I'll leave it like that. Obviously, it's not that exact number. We've been over that, 0.857. So now we have moles of magnesium hydroxide. We need to use the mole ratio between magnesium hydroxide, which was our given, and magnesium metal, which is our required or wanted. So I'm going to say 0.857, and that's moles of MgOH2. We use our mole ratio, which is the relationship between the coefficients of the chemicals that we care about in the question. So this is 3/3, so it's 3 mg's. That's my required, that's what the question asks, divided by 3 MgOH2s. So no surprises here, 3 divided by 3 is 1. So we're going to have the exact same number of moles, so 0.857. And that's going to be moles of, this time, Mg, because MgOH2 has been eliminated. Now we just have to turn moles of Mg into grams. So I will say 0.857 moles of Mg capital M, and then we multiply by the molar mass, so 24.31 grams per mole. Since we want grams, we always put the grams value up top. So 0.857, I've still got the number here, times 24.31. So it's 20.84. We only have 3 sig digs, so 20.8 grams. Of magnesium. So you do this reaction, we're not caring in this case about the aluminum hydroxide. If you measure out 20.8 grams of magnesium, you throw it into this reaction, you're going to get 50 grams of magnesium hydroxide coming out the other end. One more question before we finish up. How many grams of aluminum hydroxide are used in this reaction? Okay, so in this reaction, or in this question, we could use this value. But I want you to think about it. This value is not precise. It's one that we calculated. So it's not generally a good idea to use a value that you've calculated, especially when there is one already in the question. So I'm going to use this value here. So I want to go from magnesium hydroxide to aluminum hydroxide. So in this case, magnesium hydroxide is still our given, but they want to know how many grams of aluminum hydroxide we need to use in order to make 50 grams of magnesium hydroxide. So the starting of our question ends up being exactly the same. I'm going to do this in the single line version. So 50.0 grams of MgOH2. I have to turn that into moles. So I'm going to use the molar mass, which is 1 mole of MgOH2. How much does that weigh? 58.32 grams. 58.32 grams. Remember, if we hit the brakes here, we're going to have moles of MgOH2. Does that help us for the question? Yeah, but can we do it all in one line? Absolutely. So we went from grams to moles. Now we go from moles of one chemical to moles of the other. So my required is up top. So I have 2Al bracket OH 3. And I have 3 Mg bracket OH 2. If we stopped here, we would have moles of AlOH3. Does that help us? Yes. That's like this step in the previous question. But we want grams of aluminum hydroxide, so I need to open up one more conversion bracket, and I want to do grams of aluminum hydroxide, which is the molar mass of that stuff is 78.00 grams per mole. So we go through all of our units. We're going to see what we can cancel out. I have MgOH2 here. I have MgOH2 here. That's gone. I have moles up top, moles on the bottom. That's gone. I got grams here. I got grams here. That's gone. So in the end, we should have grams of AlOH3. So that is the correct series of units for the answer, because literally that's what it's asking us. So as long as your answer, and don't just fudge it, don't be like, oh, it's in grams of AlOH3. You need to make sure that you can show on paper or using Google Docs that you can show this process or this process, that you can show your little cancellations and whatnot. That shows to me that you know what you're doing. So let's do the quick math. So we have 50 grams. I'm going to multiply by all the top numbers, so I'll multiply by 1. That doesn't do anything. I'll multiply by 2. Then I'll multiply by 78. Then I'll divide by 58.32. Hit enter. Then I'll divide by 3. Hit enter. And then I guess I'll divide by 1, but who really cares about dividing by 1? So I end up with 44.58 grams. I only have 3 sig digs, so that means I will say 44.6 grams of aluminum hydroxide. So this is how to do mass stoichiometry. It's like mole stoichiometry. The only extra step is we have to go from grams to moles at the start. And then at the end, we go from moles of our answer chemical to grams of our answer chemical. So we'll need to use molar masses. If you want to expedite the process, I completely have no issue with you using grams per moles, aka molar masses that you pull from the internet. However, I will say to you this. A lot of the time, a lot of ionic compounds, they're hydrates. If you like Google, I don't know, copper sulfate, sometimes Google will give you like copper sulfate pentahydrate, which is a copper sulfate, which we might want in a question, hooked up to 5 water molecules, which we might not. So you need to be careful when you're using molar masses that you get online. Make sure if you're looking up aluminum hydroxide, it's the same formula that you have in the question. If it's like AlOH3.6H2O, that's aluminum hydroxide hexahydrate. That's not the right chemical, so be careful. So next video is going to be about gas stoich. It'll be not super long. I'm only going to do 2 examples there as well.